Conway's Game of Life, JavaScript, Canvas, let's go. Behind me, you can see Conway's Game of Life playing out. So this is just a 2D grid where each cell is alive or dead, and then there's some certain rules that define how each cell will survive or die in the next generation. And those rules are defined here. There's only 4 of them. So this is what we're building. So let's jump into the code and build this using JavaScript and Canvas. So we've just got a basic index HTML here. We are pulling in our index.js. We have a Canvas element. We've got a nice title. Our JavaScript is empty. So as always, we'll open up live server in the current directory. That'll pop open the browser, open up the Chrome DevTools, take a look at the console. So we are ready to go. So we'll close that and we'll start writing some code. So we'll start by grabbing hold of our canvas, document.querySelector, canvas, and then get the context that equals canvas.getContext, 2D. So we'll define a resolution. We'll say that's 40 pixels. Then canvas.width is 400. Canvas.height is also 400. So now we want to draw a grid to represent each cell within the Game of Life. So I'm going to represent that grid using a 2-dimensional array. So I'll create a function that will build that grid for us. So function build grid. And what we want to do here is create a grid. So I'll say grid equals new array of canvas.width divided by resolution. Should we put these in its own variables? I think we will. So we'll say columns equals canvas.width divided by resolution, and rows equals canvas.height divided by resolution, just so that we have those to hand. So we'll say new array of columns dot fill with null. So we have to do this so that this is iterable. So if we just say new array, that isn't an iterable, because there's nothing in the array. It's just blocked out the memory for a certain length. So we'll fill it up with null, and then we will map over it. And for each element in that, so for each column, we'll create another array, this time with rows, and we'll fill that with zeros. So now we can say const, no, we need to return that. In fact, we will just come here and just return. And then we can say const grid equals build grid. So now we'll console log that out to see we have what we think. And we have a 10 by 10 all filled with zeros. Great start. So now we want to plot a grid based on each of those cells. So we'll create another function, I'll call it render, and into render we'll pass it a grid. We'll say for let col equals 0, col is less than grid.length, col plus plus, and then for let row equals 0, row is less than grid col dot length, row plus plus, then const cell equals grid col row. And then we want to plot that onto our canvas. So we'll say ctx.beginPath, ctx.rect, and we want that to be column times resolution, row times resolution, and resolution. So this is just the X position, the Y position, and then the width and height of the rectangle. Then we'll just do ctx.stroke. See what we've got there. We'll need to call render. So we will call render, pass it grid. Give yourself some space, and let's go back into the browser. And there we go. We have a grid being plotted here. It's 10 by 10. So that's a good start. So now we want to randomly put in some living cells into our grid and then play out the rules of the game of life. So I will say, maybe we'll do it in here. We'll fill it with nulls, and then we'll map through each of those, and we will return math.floor math.random times 2. So now if we comment out that render and we console log out grid, we should see it has some 1s in there. Yeah, so here we go. We've got some random living cells within our grid. So now we can render that. Of course, nothing is actually going to render. If we take a look, we've still just got our grid because we aren't telling it to fill in the squares that are alive. So back down in our render, we will say ctx.fillStyle equals, and then we want to check if cell. So I'll do a ternary, and if cell is truthy, so if cell is 1, we want it to be black, else white. And then instead of a stroke here, I will fill. Now let's take a look at that, and there we go. So we could fill and stroke there, I suppose. Stroke. And there we go. So we have our grid with some things that are alive. So now we want to define the rules for the game of life. And I will go to Game of Life Wiki. We'll go to the Game of Life Wikipedia page. And here are the rules of the game. So any live cell with fewer than 2 live neighbors dies, as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 lives dies, as if by overpopulation. And any dead cell with exactly 3 live neighbors comes to life, as if by reproduction. So there we go. So we have this render. This just renders out the grid. But I think we're going to want another function that calculates the next generation. So I'll create that here. Function next gen grid. And now what we want to do here is create a copy of the grid, because this is something that I've run into before when I've made the game of life in the past, where I start looping through the grid and applying the rules and updating each cell, but I'm updating the thing that I'm iterating through, and that will affect the following iterations. So then we end up with this weird thing that's just not good. So all the rules need to be applied on the previous generation. So we need a copy that we can always reference, and then we update a new version of it. So I'm going to do that using some modern JavaScript syntax, where we're going to loop through every array in this grid. So obviously this grid is an array of arrays. So I'll loop through all of the arrays using map, and then create a copy of each of those arrays using the spread operator. So I will say const next gen equals grid.map, and then each of those is an array, and then I will return array spread, and that will create an exact copy of the grid array, which is what we want. And now we can actually loop through each cell in the grid. So I will say for let columns equals, in fact, I'll just copy it from here because we're using the same code. So I'll copy that and I will remove those 4 lines. So we're now looping through that. And now we want to loop through that particular cell's neighbors. So I'll do another for loop. For let I equals -1. I is less than 2, I++. So I'll explain what I'm doing here once I've written the code. -1, j is less than 2, j++. So we're looping through all of the grid and finding each cell. So that's the outer two for loops here, and then we're finding the current cell. And then we want to find all of the neighbors to that cell, and that's what these two inner for loops are doing. So I'll just draw out what is roughly happening here. So we have a grid. We might be on this particular cell here, and we want to find all of its neighbors. So all of its neighbors is this, 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 and all of these around here. Those are the neighbors. So we can think of this configuration of X and all of its neighbors as a little 3x3 grid. So that's this 3x3 grid here, drawn very crudely. And then if we think about it as a 3x3, we can iterate through it just like any other grid. So then we can say for these columns and for these rows, loop through it. That's quite simple. But what we're doing in our code is looping let I equals -1 to I is less than 2, and then j is -1 to j is less than 2. So then we can actually do it relative to the current x. If this point x is the point 10, 7, if we go -1 in the column direction and -1 in the row direction, we end up at this point here. So by using that -1, -1 configuration, we can go to this point relative to x. And then if we iterate through that, we go to -1, 0 here, and then to -1, 1 here, and then to 0, -1, etc., all the way through. So then the problem we're going to run into there is when I and j are both 0, we are on x, and we don't want to count x as a neighbor of x because it is itself. So we can do that quite simply by just discounting when both I and j are 0. So we'll say if I equals 0 and j equals 0, we will just say continue. And now we can add up the values of all of the neighbors. So current neighbor equals const current neighbor equals grid column plus I, column plus j. And then we'll have a sum, so we'll say num of neighbors equals 0. And then num neighbors plus equals current neighbor. I should be consistent about my spelling. So I'm British, so I'll spell it the correct way. Talking to you, America. So there we go. So we've got the current neighbor. So we're using colon. Oh, that's a typo. That's row. So we're doing row plus I and row plus j. So that's giving us all of the neighbors. And we're discounting when I and j are both 0, so we're not counting ourselves. So that gets the value of the current neighbor. So if that's a 0, there's no living neighbor there. And if it's a 1, there is a living neighbor. So we can just add the current neighbor's value to the number of neighbors. And then that will give us, at the end of this for loop down here, if we give ourselves some space, not too much, that will give us the number of neighbors for the current cell. So then we can apply the rules of the game right here. Now I need to remind myself of the rules. Any live cell with fewer than 2 neighbors dies, as if by underpopulation. Okay, so if cell is 1, so if we're alive, and num neighbors is less than 2, is that what it said? Less than 2? Fewer than 2, yep. So if we're alive and we've got less than 2 living neighbors, then we want to kill the current cell. But we don't want to do it on grid, because grid is what we are looping through. We want to do it on next gen. So we'll say here, so we'll say next gen call row equals 0. So we want to kill that cell in the next generation. Else if cell is equal to 0 and num neighbors is greater than 3, I think that's the rule, any live cell with more than 3 neighbors dies, as if by overpopulation. So if we are, it's if we are alive. So if cell is 1 and neighbors is greater than 3, then next generation equals 0. Else if cell is dead and num neighbors equals 3, then next gen call row equals 1. And then the else case will just be it stays the same. So that's the second rule here. Any live cell with 2 or 3 lives on to the next generation. So if our current cell is alive and the number of neighbors is less than 2, we die. If our current cell is alive and the number of neighbors is greater than 3, we die. And if our current cell is dead, but the number of neighbors is exactly 3, then we come to life. Otherwise, we just stay the same. And we don't need the else block here because we can just assume that we are the same because next gen started off as an exact copy of grid. So if it was an exact copy of grid and we do nothing, that cell will obviously be exactly the same as it was. So now at the end of this, we can just return next gen. So now we need to call our next generation function. So we will probably need to say this is let, not a const. So we're building the grid, and then grid equals next gen grid, and then render grid. So this next gen and then render should be called on every update. So I will create a function called update, and we'll put this into here. And then I'll call request animation frame update. And then at the end of this, I will also call request animation frame with update. So now, if we come into the browser, we have an error. Cannot read property -1 of undefined. Okay, so we've run into an issue here. So the issue is the edges. We need to deal with the edges. So when we are on column 0 and I is -1, we're trying to get into grid -1. That doesn't exist, that's undefined. And then we're also on row 0 and j is -1, so now we're trying to get row -1 of undefined, and that's the error that we're getting. So we need to handle the edges. So I'll start by pulling out this column plus I and row plus j into their own variables, so then we can do some checks against them. So I'll say const x cell equals column plus I and y cell equals column plus j. So now we can do some checks. We'll give ourselves some space and we can say if x cell is greater than or equal to 0 and y cell is greater than or equal to 0 and x cell is less than columns and y cell is less than rows. So that's just checking that this cell that we're trying to check, the column plus I, I've done another typo here, come on man, row plus j. So this is just checking that the cell that we're trying to check isn't outside of the boundary of the grid, so we're not going to get undefined. So that's what this if is doing. And if we do pass that test, then we can grab hold of the current neighbor and add it onto the num neighbors. So now we save, come back into the browser. So we have assignment to constants on line 44. So line 44 is here, num neighbors. Yeah, here we go on. Here we are deciding that that was a constant, but that is not a constant. So we'll just make that a let, come back, and there we go. We have a game of life. That was very quick. So let's make our grid a bit bigger and put more cells into there and see what happens. We'll come up to the top and we will say our resolution is 10 pixels, our width is 800, and our height is 800. So now let's have a look. Ta-da! We have the game of life. So what I'll like to do here is remove the stroke. So I'll remove that stroke, and that looks quite good. So there we go, the game of life. That's a very basic implementation of the game of life, and there's lots more we can do. And I think I'm going to make another video, because there's a few things that I've wanted to do with the game of life for a while. And that's different ways of visualizing it based on the historical state of a given cell, for example. So I think I'll do that in the next video. But if you enjoyed this video, give me a thumbs up, hit the subscribe button, bell notification, all that good stuff. If you really like what I'm doing, I have a Patreon, so you can check that out. Link is in the description. But until next video, stay hungry and keep coding.